Hi everyone, today let's solve the Leetcode question called three sum closest. So, given integer array or length n and integer target, we want to find three integers num such that the sum is closest to the target. So see the difference here from the previous question 3 sum line. So the first difference is that our target is not always 0, right? And the second difference is that we want to find the sum that closest to our target but may not exactly match with the target. Okay, now understand difference. Let's check example 1. Example 1. We want to find three numbers from this array that best closest to this target ones, right? So if we select this -1, we select 2. Select this one, we get the best match because 2 is closest to 1. Okay, now we check examples. Let's think about how to solve this problem. So to solve this problem, actually we can hold one variable called best sum and one variable called current sum. If the current sum is closest to the target than the previous best sum, we want to update the best sum to the current sum. And let me write a drawing here to help you understand. Okay. Actually, we need the best sum. And let's say we initialize the best sum as the sum of first three elements. So based on these three elements, right? It will be -1 plus 2 plus 1, and we get 2, right? And after that, the next step is sort the array as we did in three sum. So just move this array here. So we have more space. Okay, so write the array here. And okay. Now I move the array here. Next step, as I mentioned, is sort, right? So this sequence should be changed. And I will change these numbers. The first element now is a -4. And second element is -1. Then we have 1 and 2. So this array is now sorted from the smallest element to the largest element. Now we sort the array. The next step is to keep a variable called current sum. So the current sum is the numbers at pointer I, which I will write later, numbers at pointer left, and also the number at pointer right. Okay. So now let's initialize pointer I at the first number. So let me use this color for pointer I. I will be here. And let me use a different color for left. So left will be here. And we'll use different color for right. And right was starting at the last. Okay. Now you see the current sum here. The current sum is numbers left. We have -4. Numbers right, -1. And numbers right. So we have these three numbers sum together. And we get -3, right? So we see -3. The first step we have to check is current sum better than best sum? And we see, okay, the distance from -3 to 1 is actually bigger than the distance from 2 to 1. So current sum is so far not as good as best sum, and we don't want to update the best sum. The next step is check the current sum relationship with target. So we see current sum is -3, so it's smaller than target 1, right? Therefore, we must move the left pointer right to search for bigger values. So let's move the left pointer right here. And now our numbers left change to 1, right? So let's change it here to 1. Okay. And now our current sum is updated to -1. But -1 is still smaller than 1. However, here we cannot move the left pointer or right pointer further. And the only thing we can do is to move the I pointer to the right to search for greater values. So let's move the I pointer to the right. And let's write it here. Okay. I pointer is now here. And want to calculate current sum, right? And you see the current sum is -1 for number side. So we just change it down here to -1. And now you see you take -1 plus 1 plus 2, the results will be 2, right? So change this -1 to 2. And now, first thing to compare the current sum with best sum, or the current sum equal to best sum. So there's no need to update the best sum, right? Now, second step, check the current sum with target. Now, if our current sum is instead greater than target. So we want to move the right pointer to left to decrease the value, right? However, we have already stuck all these 3-pointer at the end. There's no space to move the right pointer to left, and we have to stop the traversal. So these two will be our best choice, and we return the two result. Okay, I hope my explanation will make more sense. And now let's dive into the coding part. Okay, so first let me write a general framework, and we can continue. So first, let's initialize numbers, and let's initialize the best sum, which I randomly pick at numbers 0, numbers 1, numbers 2, and then sum. Okay. Next thing is sort the array. So I'll put 2-point search later will function. And after that, we want to traverse this pointer I from the beginning to leave two more space for the left pointer, right pointer, and right. And after that, we want to run 2.22. So just run 2.2 search. Okay. So for 2-pointer search, we need left pointer started at I+1. And we need the right pointer started at L-1, indicating okay, it's the last position. And after that, while left is smaller than right, this means okay, this 2-point search is still valid. And the first thing we want to consider is calculate the current sum. So we can compare with best sum later. The second thing we're going to consider is to update, right? If the best sum is great, the best sum is not good, and current sum we have to update the best sum and current sum. After that, want to check it's small, is it large, or it match. As we did in the previous example. Finally, return the best sum should down. Okay, now let's write code. The current sum is numbers I plus numbers left plus numbers right. Okay, and usually the absolute difference of current sum minus target is smaller than the absolute value of best sum minus target. If that's the case, we want to replace best sum with current sum. Okay, now we want to check the current sum's relationship with target, right? So current sum is smaller target. This means our value is too small and to check right for greater values. So move the left one to the right. And otherwise, okay, current size is greater than target. This means our current value is too large. We want to move the right pointer to left, right? And otherwise, we just keep moving the left pointer to the right to search for the next pairs as we did in previous question. However, you see here for small and match, we have same result, right? So we can add these two categories together at smaller equal to, and change this little bit to else, so we can save some coding part. Okay, now final thing to return the best sum. Now let's take a quick scroll code to see if we make any typos. Okay, now let's meet the result to see it works. Okay, you see the time capacity, memory usage of this solution is not bad, right? And I think it's relatively easy to understand for the coding part. If you like this video, please subscribe to our channel, and I see you next time. Thank